Today we'll talk about strategic data gathering. Um, and my goal is to explain to you why strategic data gathering is an important tool for effective visualization. And we'll identify some of the common pitfalls in data collection. So some of these can compromise your visualization quality. And the overall or the overarching goal is to be able to apply this your strategic thinking to decide what data to collect from where, from how, right? And be able to evaluate the trade-offs between data availability, the quality, and scope. We can do that today, then we've done a lot, I think, for a short 45-minute session. This here is an example of a misleading chart versus an accurate chart. Now, on the surface of it, if your eye isn't trained, you may see, so like, well, I don't really see too much of a difference. But if you kind of dive in a little bit deeper and see like, well, this is misleading because you have this bar graph going well past 450 on the B column and well past 425 on the A column, whereas it's completely different here on the right hand side. I mean, you could argue for both ways, you know, the one on the left is correct or the one on the right is correct. Whatever the case is, one of those is incorrect. The point that I want to make is labeling. Someone mentioned labeling. Labeling is of utmost importance. I cannot stress labeling your axes. In this case, that's one other thing I would add here is I would label your y-axis. What is this exactly? What are we looking at? 430 widgets? Say if I was a stakeholder, and it really depends what industry you're in. So know your audience, right? I think in banking or finance, they have a lot more uh, you got to match the energy in the room, right? In marketing meetings, I suppose, people are real sticklers, especially people with a lot of money. If they're investors and they see something like this, they'll throw this in the garbage. I don't want to waste my time on something I don't understand. But you have to be ready for all kinds of personalities and stakeholders. It's a little bit different in healthcare. Um, I think they focus more on the medicine and the science than, they might make a comment here or there, but they're not going to be so abrasive. Um, all right. So, all right. So then, yeah, there's a lot of ways that charts and graphs can be misleading. Um, these are just some examples, but I really want you guys to focus on developing and cultivating that attention to detail. It sounds like, well, hey, I know what to do, but it takes practice nonetheless. Watching out for dotting your I's and crossing all your T's like that. And it takes time as well. So at a minimum, definitely label your axes and try to convey all the information in the visualization because the ultimate goal of that visualization is to tell a story. You may not be able to do it with one or two, but you should be able to do it with a maximum of 7. So, um, as we transition, just understand hopefully that the problem starts well before the visualization. It starts in the data gathering stage, and that's what I'm looping back to. That's the kind of like the name of this session is data gathering. And so it's not just data gathering, it's strategic data gathering. You're not just collecting all possible data, but you want to be able to gather the right kind of data. And where are you going to get that data? It has to be relevant, it has to have quality, it needs to be practical. And nowadays, you can argue, well, where am I going to get all this if I have to independently source all of my data? If my employer or stakeholder didn't give it to me, I have to get it myself. And then sometimes that's the case. Sometimes the data is given to you. It just depends on which sector you work in or around. But you have to ask in terms of relevance, does the data directly address the problem? In terms of quality, is it accurate? Is it complete? Is timeliness involved? Is there consistency? And in terms of practicality, what's the feasibility in if we're dealing with cost, time, access? Those are really important things. But the big question is, where do you get the data? The data sources, right? There are several different ways to collect the data. You can collect them through primary sources like surveys, experiments, direct observations, or secondary sources, like if you have connections to APIs, for example, on redfin.com, or if you have access to internal databases. Those are all great ways to collect data. It really makes you think hard about, where can I get data that's not your standard run-of-the-mill Kaggle data set or something that 20,000 other people have worked on? Where can I get data that's clean? Well, you're going to have to clean it, unfortunately, at some point, but clean enough to look at, and something that answers a specific research question. It's challenging, and it makes you think, and it makes you work hard, looking for something on the internet that may or may not involve today's modern LLMs. Regardless, it's still a task. It still takes time. But has anyone ever had such a conundrum? I will say, my goal is to give you a few sources that I am aware of and kind of guide you through that monotonous, soul-crushing, mind-numbing task, if I may. So one of the data sources that I'd like to point you to is redfin.com. Why redfin.com? I think real estate is a great common denominator for people in various walks of life that have different career paths, because I think looking for housing, or even being interested in what the cost of housing is something that we as humans want to explore, especially with changes in the economic sector, things that are happening today, prices going all over the place. And some argue they're going down. I think they're going up compared to where they were 12 years ago. And I don't think they're going down enough. But I think real estate, aside from all that, is great because you have a simple task, is that you look at a house's number of baths, bedrooms, right? And other attributes like the year that it was built, the square feet, and so on and so forth. And based on that, you can predict price. You're not going to necessarily be building a predictive model in this course here for the visualization piece of it. But as you progress, that final course will ask you to build a multiple linear regression model. And I just basically gave you a project. But what I like about redfin.com, and I will pull that up in just a second, is that in a sense, it is real world data. It is real time, as real time as it gets, without you having to purchase anything, connect through an API. It is just there for you to peruse, and it's available on demand. So let me go ahead and share my screen rather quickly here. We can pick, I live in the Los Angeles area, unfortunately. We can go ahead and pick something different, perhaps. Does anyone have any preferences or interested in looking at a specific zip code or city? If not, I can type one in. Let's go with Brooklyn, in case someone feels strongly against that. Brooklyn, New York. When we search, and for some reason, what do we have here? Oh, we're in Brooklyn. That's great. When we search for the city, should give us images that belong to all of the results for that city, but for whatever reason, they seem to have changed the user interface since I last looked at it. Perhaps if we type in a specific zip code, let's see, Brooklyn zip codes, 11212. And again, I'm not, there we go. Let's try that. Okay, that's what we want to see. It kind of locked up on us for a second. And they have changed the user interface for sure. Scroll down to the very bottom of the search results, unless you want to just look through them one by one, but that would take quite a bit of time. And at the very bottom, we have this neat feature that says download all. When you download all, what you'll have immediately is an Excel spreadsheet, but it's really a CSV file, comma separated values. So I'm just going to warn you from the very beginning that if you start making any kind of formatting changes to it, like highlighting things and doing conditional formatting, for example, highlighting cell rules, anything like that, and you save that over the CSV file, none of that is going to save. None of that will be stored because even though you open this in Excel, it's a comma separated values file. It's really meant to be open in, for example, Python or Notepad or some other software. Excel is just one of those softwares. So what I would recommend is if you're going to use Excel in perpetuity for this course, is to immediately file save as, browse, select the path, and change it immediately to Excel workbook .xlsx, and then save over it. And then whatever you do, you can keep it that way. So we'll keep this open. This, I think, is a really neat way to gather data because everything is available immediately in tabular format. The only limitation, well, apart from having a blank row, which you can delete, and that's another thing too. When you see structured data, you want to make sure that you don't have an entire row of missing data because everything needs to be structured, everything needs to be tight, and there's no reason to have a row with missing data. For those that don't work with data analysis, people that just put together tables for reporting purposes may not understand that, but it's a very common pitfall, is that they think it looks neat if they have a blank space because it separates the header or the title from the rest of the data, but it really does create a lot more problems than are necessary, and you'll see that later on. So you don't want to have any missing data that could be avoided. There's missing data here, for example, for the zip code, which is fine because it wasn't available at the time of collection. So same here for number of beds, or here for number of baths. And I'm just going to give you a little bit of a time travel to the future scenario here is when you do build a predictive model, you will see that you will need to fill these missing values with something like the average, for example, because the model cannot take in missing data. But that's a different type of missing data. It's sporadic here. It happens a few times in the middle. And it's common. But what I'm saying is you don't want to have an entire row that just blank for no reason. That's just the formatting, unnecessary formatting thing that you shouldn't have. All right. I like this data set. I don't know what your opinions are on this data set, but it's as real as it gets. These are real addresses in Brooklyn or whatever zip code or city you look at. And you can build predictive models with this. You could, to predict price right here, or to just visualize what the market looks like. And it's not something that was available on Kaggle or UCI machine learning repository for the last 5 years, or what are some of the other ones like Harvard Data Reverse. So whatever you choose to use for this course for visualization purposes, whether you go with the data set that's already available through the course itself or not, that's up to you. I don't care as long as you deliver the project. For some of you, it may matter because maybe you're building a portfolio and you want to make it very impactful and relevant. That's all on you. I just want to make sure that you just go through the motions and complete everything as asked for. Here's another popular data repository Kaggle. Some of you may be familiar with it. It's simple. You register with Google and you can look for different data sets here. There's one on Uber, all kinds of different ones. Sales data set for those of you interested in sales. Let's look at that one. Uncovering trends in Nigeria sales data. And most of the time it's as simple as just clicking download up top. And you should be able to download a zip folder with CSV files. So it does take a little bit of time to search and sift through these. Another one that I think is extremely popular, in my opinion, is data.gov from the US government. You can see that there are 352,000, well over that, data sets available. This one takes a lot longer to sift through because the data is available in so many different formats, JSON files, ArcGIS, CSV, Excel. So I don't know, if you just click on data, here's a random one, electric vehicle population data, and there's a CSV right there. This one's from the state of Washington. We're looking at battery electric vehicles and plug-in hybrid electric vehicles that are currently registered through Washington State. So it does take some time to sift through these and to see what's relevant and what's not, what you can or cannot use, what will or will not be helpful to you. So let's see what this one looks like rather quickly. Anything I don't source myself, or anything I'm not familiar with is very difficult to understand. Oftentimes you need a data dictionary to kind of walk you through the data set and tell you, all right, well, what does this mean? What does this column mean? What does that column mean? I don't know. And this, sometimes it's self-explanatory, like here in this case, we have the VIN number, the county, the city, and so on and so forth, the make and model of the vehicle, census tract. But I may ask, like, what can you build from this? What can you visualize from this? I don't know anything about electric vehicles. For those of you that do, this could be an amazing data set, especially for visualization, because you have electric range, the base MSRP, very strange. See, a lot of these are zeros. So I don't understand that piece of it just by looking at it rather quickly. So it takes time and it takes context to understand the data set more fully. So you can open that up and kind of read through it and figure out what's what, and hopefully you'll find a data dictionary. So these are just some examples of strategic data gathering. Has anyone used anything else? By the way, you could also find one for your city. Oftentimes, let's say Los Angeles has an open data portal that I'm familiar with. So you can look at it at the city or county level as well. And I can't promise you that your city or county will have open data portals, but it's worth looking at by just doing a simple Google search. For example, New York City open data. You could look at it at the federal level, or in this case, state level or city level. There's so many ways to curate, find data, but it does take time. In terms of healthcare, it's a bit harder, but there are some popular ones that if you need a quick healthcare or science data set, you can go to the UCI machine learning repository. And these are standard run-of-the-mill data sets that you're going to see in pretty much every introductory machine learning project. Like this is a classic one, iris, wine quality, heart disease. If you work with these enough in a data science program, you'll know these in and out. Like you'll know that these have been tried and tested hundreds of thousands of times by so many people. But if you want to get more nuanced, you can click on view data sets. Again, folks, this is the UCI machine learning repository. You can filter everything by keywords, attributes. I personally have built predictive models with respect to end-stage kidney disease. So I'm familiar with CKD, and there's one here, chronic kidney disease, or risk factor prediction of chronic kidney disease. So if you click on something like this, you'll see the creators. This is very often attached to a paper. So you can read the paper that belongs to that. There's a DOI. Actually, this one's attached to this repository itself. But if you scroll through it, what's really nice here is there's a bit of a data dictionary, the variables that are available, the additional information, what each of these mean. This is kind of what you want to have in a perfect world, right? But you're not always going to get it. So anyway, these are just some examples. There's different struggles and challenges is what I want to say with respect to data gathering. And there's no wrong answer here. That's what I'm trying to say. There are things what I love in teaching data science or data analytics is giving you a straight statistical answer on, hey, if we look at the p-value of this variable, is it statistically significant or not? We can all agree or disagree on that. It's scientific, right? But when it comes to something like this, data gathering, especially if it's outside the scope of your organization, or if it's more general, or you're just tasked with finding a data set and it's not really specific to a certain objective, you have to find your own objective, you have to find your own use case, and you solicit the help of an instructor or of course facilitator. It is a challenge for all of us, but it is something that takes creative thought. And I think that that's one of the things that LLMs cannot necessarily take away from us. They can help with that aspect of things, but it still takes a lot of human thought. So I hope that's comforting to you. And you'll see over time that you will need to put a lot of your own human input and make avoiding mistakes, for example, like I've shown you earlier on that graph. So analytics is still very much a human trait. I will stand by that to the core. Anyway, so those are just a few examples of strategic data gathering. We can go on and on for hours on, different repositories, like I mentioned, Harvard Dataverse. If you want to write this down, there's also Mendeley data, which is attached to scientific research paper. That one is either a treasure trove or just a complete nightmare to sift through, because you'll either find, not all research papers have available data, and they're not going to give you data unless they do so willingly. But that's really, it's a hit or a miss. Mendeley data. The reason I like that one is because it also has a filter, kind of like UCI machine learning repository. So the goal here is not just to look for data, but to be able to do it strategically, right? And you have to figure out what is the right data for the question that you're trying to answer, and who is your audience. Remember earlier I mentioned there's different kinds of audiences. I remember when I first wanted to get into finance and I did an internship with Merrill Lynch. This is way back in the day. And I was very excited to be there. And I told the manager that this is amazing. I'm going to be looking through all these records and helping you make a lot of money. And he said in certain language, to sit down and be quiet. I'm not going to let someone like you run my business to the ground. So you're going to listen up and you're going to listen good. And so, there's different there's different stakeholders. And I knew right then and there that there's a certain way that I have to communicate with that stakeholder versus someone else from a different field. It is what it is. And so, but when you collect the data, you have to make sure that, again, it's the right data, right, for the person that's going to be interested in receiving it. So we mentioned that there are three pillars. That we have relevance, quality, and practicality. And in terms of collection, I've just gone through what I know through my experience as viable sources. If you're also interested in healthcare data, I think AWS, that's another one I forgot. AWS has someone some of those available as well. But for some of these, they're protected behind like a wall, so you have to reach out to the organization and fill out some forms, and they'll approve it or deny it. It just depends on who you are and where you're coming from. They evaluate that on a case-by-case basis. But so what I want to say to kind of close this loop is there are trade-offs here, right? In terms of these core concepts of strategic data gathering. And so you have to balance the broad versus deep data sets, right? Some of them don't give you very much information. How deep do you want to go? How many layers deep? Do you want to be able to look at the type of housing as it pertains to real estate? So let's pull that up one more time just for context. Broad versus deep, right? And that matters because there's surface level and there's granular, right? Right now, what we're seeing is surface level, right? If you want to drill down and not just look at price, beds, baths, you could also look at the property type. So if we do a drop down on column A, you can see that these properties are delineated as multifamily 2 to 4 units, multifamily 5+ units, single family residential, townhouse, vacant land. So you can pivot this and create visualizations based on these 5 categories. That's what I mean by deep versus broad. That's just one example of that. How far do you want to drill down? And something we mentioned about this data set is also historical breadth versus recency or freshness. This is fresh. This is recent. This is real. This isn't something that's been out there for 5 years. I mean, I can't tell you how recent it is, but I know that in terms of the today's timestamp when we pulled it, this is as recent as it gets from Redfin.com with respect to that zip code. So these are some of the trade-offs you have to ask yourself.